Switch embedded teaming allows us to go ahead and take multiple network adapters and create a team that are connected to a switch. And at first glance, we might say, well, isn't that a lot like the load balancing and failover function of NIC teaming, where we have multiple network cards as a member of a team? And the answer is yes, there are a lot of similarities. And so the next question might be, well, why in the world do we have this whole new way of doing teaming if NIC teaming worked great? And the answer is NIC teaming breaks or doesn't allow some of the features that we might want to use. For example, remote direct memory access on a network card. If we want to take advantage of that feature, NIC teaming doesn't allow us to. There's also a lot of other features that are used as part of SDN version 2, including the VFP, the virtual filtering platform, and if we're using the older NIC teaming as part of load balancing and failover, some of those additional features that we want to use, we can't. And so that's why we have this option of switched embedded teaming, so we can use additional features in hardware like RDMA and other software and hardware features that otherwise would not be able to be used if we were still using NIC teaming. Some other differences between NIC teaming and switch embedded teaming is that we don't create a name. In NIC teaming, we give it a name. With the switch embedded team, we would use System Center Virtual Machine Manager, or we could use PowerShell to go ahead, for example, and create a new switch and automatically associate the adapters that we want embedded as part of that switched embedded team. Another difference is the mode of setting up the team. With NIC teaming, we have the option of link aggregation control protocol, or static, or switch independent. And with SET, the only option we have for setting up the members is going to be switch independent. Another difference is that there's not the option of taking one of these adapters and saying, hey, you're going to be the standby. In SET, they're all going to be active. And if one interface fails or no longer can communicate, the other members in the set will continue to do the forwarding. So what I'd like to do is walk you through how we can set it up. We'll use DCNUG as the server in our lab environment that will go ahead and create a new switch, and we'll go ahead and set up a couple adapters as switched embedded team members. So here on DCNUG, let's go ahead and open up Server Manager. And in Server Manager, we'll go to Tools. And from the drop-down, let's launch Hyper-V Manager just to see what we have. And then over here in the Actions pane on the right, let's go ahead and click on the Virtual Switch Manager. And currently I've got one virtual switch. And just for grins, I'm going to highlight that and I'm going to remove it. So we have no virtual switches at the moment, and we'll click on Apply. It gives us a warning. This may disrupt some people trying to use that switch. We'll click on Yes. And now we have currently no virtual switches at all in Hyper-V. Fantastic. So if we wanted to create a brand new switch and have a couple of adapters as part of switched embedded teaming, let's first of all make sure we know what adapters we have to work with. So I'm going to go back to Server Manager just for a moment. And on the left-hand side, we'll click on Local Server. So we've got adapters 2, 3, and 4 that we could all include as part of the switch embedded teaming. So let's go ahead and open up the scripting environment by clicking the icon for that down in the taskbar. And let's issue the command get-vm switch and do an F8 to launch that, just to verify that we have no switches. We saw that in the graphical user interface as well. So let's create a new switch with the command new-vm switch space, and let's use dash name, and let's go ahead and give it a name. Let's call it our set vSwitch. And then let's include our network adapters. We'll use a dash net adapter name space, and then we'll put in the 3 adapter names. And I forgot what they were already. Let me go back and look at Server Manager. So it's Ethernet 2, 3, and 4. Fantastic. So we'll go back to the scripting environment. We'll put a quote in, and then we'll specify Ethernet 2, close the quote, comma, open quote, Ethernet 3, close quote, comma, and then open quote, Ethernet 4, and close quote, and a space. And then we'll do a dash enable embedded teaming, and then do a $true, space, and we're set. And so with our cursor at the end of row number 2, we'll do an F8 to go ahead and execute that, which should create our new switch and apply those 3 Ethernet interfaces, 2, 3, and 4, as part of the switch embedded teaming. And if we go back to the Hyper-V Manager, and then go back to the Virtual Switch Manager, let's go ahead and cancel that, and then bring it back up so it has the latest and greatest information. So on the right, we'll click on the Virtual Switch Manager. There we have our switch that we just created with the 3 adapters that we specified supporting the switch embedded teaming. So now we have the benefits of additional throughput and fault tolerance, and we can still use the more advanced features like RDMA and many of the SDN version 2 features that otherwise would be broken if we tried to use the older NIC teaming. And now, my friend, it is your turn. Go ahead and launch the hands-on lab and do some practice creating a switch that's leveraging switch embedded teaming. And I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.